Hey everyone, let's solve the first question from today's weekly contest, that is apply operations to an array. You're given a zero indexed array nums of size n consisting of non-negative integers. You need to apply n minus 1 operations to this array where in the ith operation you will apply the following on the ith element of nums. If nums I is equal nums I plus 1, then what we have to do is we have to increase nums I by 2 and set nums I plus 1 to 0. Otherwise you skip this operation. After performing all the operation, shift all the zeros to the end of the array. For example, this is some array that is given to us, and as you can see there are some zeros, and after shifting all its zero to the end, this is what array looks like. So we have to then return this resulting array after performing all these operations and shifting the zeros to the end of the array. And note that the operations are applied sequentially, not all at once. Okay, so let's understand this problem statement first. So basically, in this question, we are given an array and we have to perform some operations on this array. And those operations have to be performed sequentially. Now, what are the operations? So basically, we have to take ith element of this array and compare it with I plus 1th element, right? So after we do this, we have to check if these two elements are equal. So if these two elements are equal, we have to replace the ith element by the double of it, right? We will multiply 2 with the ith element and replace it inside this array, and then we have to change the I plus 1th element to 0, right? So let's perform these operations onto this array, right? So right now we are here, so we'll compare it with the next element. So they're not equal, so we'll simply move forward. Now we are here and we will compare these two elements. Now they are same, so what we have to do, we have to place twice of 2 here, right? Twice of the element that is present at the ith position, and we have to put 0 at the I plus 1th position. Now we were here, now our I is here, right? So basically our I is here, and as we are saying that we have to perform this operation sequentially. So if we want to perform this operation sequentially, we have to take in account to the array that we currently have, right? Not the original array. So okay, so we are here. So we compare 0 with the next element. 0, 1, they are not equal. So our I is moved forward. Now we compare these two elements. So they are equal. So we have to double the ith element, which is 1. So we'll have 2 here, and we have to replace the I plus 1th element to 0, right? Now our I is moved forward here, right? And the next element is this. So we compare these two. So again, what we have to do, we have to replace the ith element with the twice of it. 0 into 2 is 0, right? And we have to replace the I plus 1th element to 0, right? So now our I is here and we can do no more comparisons. So our array is 1, 4, 0, 2, 0, 0, 0, right? So this is okay, only 1 0 will be here. All right, so this is our resultant array. Now we have to do one more thing. We have to shift all the zeros to the end of the array. So our answer will be 1, 4, 2, 0, 0, 0. All right. So now it must be clear to you that what we are doing, right? So let's see how we are doing. So we are basically traversing in a for loop. All right, we are just traversing in a for loop, and we are checking if nums I is equal nums I plus 1. If it is, we have to simply replace nums I with nums I into 2 and nums I plus 1 to 0, right? Now the other thing is, now notice everything is done in place here. We are not taking some auxiliary space and consuming it. We are doing everything in place. All right, now let's see how we are doing the second thing, that is moving all the zeros to the end of the array, right? So you can also use the brute force approach, right? But I'm doing this in O of n complexity. So let's see how we are doing that. in O of n complexity and O of 1 space complexity. All right. So here what I have taken is int count. Now what this count is doing is it will uh, it will keep increasing. As you can see, we have put this condition: if num size is not 0, it will keep increasing until we find a 0. So when we find a 0, we are basically, our count will be pointing to that 0, and when we will again come into this condition, we will be basically swapping the 0 with the number that is after that particular 0. So let's see how this is working. So basically what I'm trying to say is, right, so the array that we had got was 1 4 0 2 0 0. What I'm saying is, I'm taking this count variable, let's call it C right now. So what we are looking for is, if any element is not 0. So if it is not 0, so we have to basically do what? We have to swap that array element with this, right, wherever the count variable is, and also do C++ here. So basically we are at 1 right now, so C is also 0 and this is also 0, so no swap happens. Then we move forward. So right now, because of this condition, that whenever we find an element that is not 0, we have to increase the count, right? So our count is now our count is now 1. All right. So again, this is also 1th position, right? This is 1th position and our count is also 1, so no swap happens, right? Now see, again now as per this condition, our count is increased to 2. Now we reach at this position. So at this position we have to do no swaps, and at this position our count stays at this position because we're not incrementing it. So our count is now pointing to this 0. So now we reach this element, right? As soon as we reach this element, we again enter into this condition, right? As soon as we enter into this condition, so these two are swapped because our count is pointing to this and our current array element is this. So these are swapped and what we get is 1 4 2 0. So you can take more examples and understand how this algorithm is working, right? So this is how we're putting all the zeros to the end of the array, and after we have done that, we are simply returning nums because all the things that we have done are in place.